Hello everyone. Today's topic is idempotency. We are going to go deeper into idempotency questions. I'm sure that you know already what is idempotency, how it works, but still, while in interviewer would ask some of the questions related to idempotency, which are very tricky. And I'm sure that after today's video, you would be able to answer all those questions and frame your answers pretty well. So stay tuned. You're watching Underflow with Chichi. Idempotency in payments. Now here is the thing. Whenever you're searching idempotency on YouTube or anywhere on the internet, most of the articles or videos you will get idempotency in payments or idempotency in API of payments. Why is that? Because payment is very critical uh, operation when it comes to charge twice. Idempotency means a similar kind of request should land on the similar kind of results always. So we are going to understand this from a ice cream example. Now, for example, you're ordering ice cream on a crackly walkie-talkie. Suppose you have a walkie-talkie and the ice cream parlor person also has a walkie-talkie, and you order that, hey, one chocolate cone, please, on the walkie-talkie. Now, suppose it's a crackly walkie-talkie. Your order never reached to the person whom you're ordering, and you never heard back from the person. What would you do? Will you say it again? Of course, you will say it again. But what if that person already heard it and he started working on your ice cream and then he received another request from you? So it's you and you're not intent to have another request, but because you never heard back from a person, you have to make the request twice. That makes that your requests are not idempotent. Whenever you're requesting for an ice cream, you are saying, "Hey, I want a chocolate cone," and if what if you heard back that okay, I received your payment, that okay, I received your order and your ice cream will be ready, you will be safe. But if you haven't heard back and you have to make the order twice, that means you may get charged for two ice creams where you are not supposed to. Now, what are the challenges? What are the solutions? Now, why can't we just prevent the retries? Why can't we just say that you should not say it again? Like you just said it once and assumes that your request will always reach. That does not happen in all the systems. So availability is one of the factor in that. Suppose the other side is not available to receive your request. In that terms, your request will never reach and someone has to retry. Now, the network will always drop messages every time and the client that hears nothing will resend. That's correct behavior, not a bug. So we don't fight the repeat. We make sure that repeat lands on the same result instead of creating a second one. Idempotency equal to repeats are harmless, not forbidden. Now, a question comes, and this is very interesting. If you ask me, I come from a front-end background, and I know that this question comes a lot in interview. Who makes the idempotent IDs? Is it client or server? You would laugh and say that it's pretty much clear server would make it, but no. Even if client is making that ID, there is no harm because the site who is doing the retries should make the IDs. That is the only catch here. Now, for example, your server is talking to payment gateway. When your server is talking to payment gateway, your payment gateway is giving you the results that okay, we have received your request and your payment is done, and here is the response. In this, two things can happen. One, you will get the response. Second, you would not get the response back because of the network unavailability. If you won't get the response, whom you want to do the retry? Should it be your mobile application or should it be the server who is actually talking to the payment gateway? In my view, the retry should happen from the server who is talking to the payment gateway. We will understand in this way.
So here,
This is your mobile application. This mobile application is talking to one of the server, and this server is talking to one of the payment gateway. Now understand this. When I'm saying that server should do the retry, why I'm saying that and why not mobile? Because for example, your mobile creates the ID XYZ. Your mobile has to save it. And suppose this payment gateway sends no reply. There is no reply from here. This will also give you timeout. Here, the thing is you have to again send the same XYZ on the server, and then server again go to the payment gateway. One thing, keeping this idempotent IDs on mobile is not safe, first. Second, when you will have 100 million mobiles, and there are chances that someday one or two IDs will collide, and you don't want to do that. So for that, what you have to do is you have to create these IDs on server. How to create the idempotent IDs in a distributed system is another discussion point, which we will cover in some of our next videos. How to create unique IDs on the distributed system. That is something which we will cover next. But for now, understand my server should generate the unique idempotent ID. This will send to payment gateway. Payment gateway will get it back. By the way, this is also a wrong move. We will understand why. Ideally, you should reserve your space at the payment gateway. Payment gateway should give you ID back, saying that, hey, this is a XYZ intent, and all your payment should only happen on this XYZ. So server only needs to save it somewhere in the DB, not generated by itself, because payment gateway is my source of truth here, and payment gateway is handling servers like these, many servers like these. So payment gateway should start getting the intent and should give the idempotent ID back to server. Server should save it somewhere, and from there it should give back results to the mobile application. This is one part. Now, do all the steps need to be this careful? First, you reserve a cone, like I said, reserve a idempotent ID, and then later you pay for it. Two different steps. So reserving can be sloppy. Suppose again, for example, payment gateway started one intent with XYZ. This XYZ is your idempotent ID. Your server actually saves it in one of the cache and then gives it back to the mobile site. For example, if this doesn't happen, this never reached to mobile, what will happen? Nothing will happen. Basically, mobile will say, hey, I want to pay. Server will say, okay, let me save a space for you. Let me say reserve a space for you with which you can pay. And server will ask payment gateway that, can you give me another idempotent ID or intent? Payment gateway say, yeah, this time you can use ABC. Server will go and save this ABC in your cache. Now your question is, what would happen to XYZ? So after a TTL, XYZ, we can delete it. There is no harm basically there. And then you can actually start doing the payment on this ABC next time. So I hope you understood what I'm trying to explain here. Reserving can be sloppy. Reserve twice by accident, no harm. Nobody paid. The leftover reservation just melts away on its own, or TTL cleans it up. It's a little litter, not a bug. Okay. But paying cannot. Paying is the moment money leaves your pocket. So if you are paying twice, it's real. It is real harm. You are losing the money. This is the only step where repeat hurts. Okay. So where you would ask that where exactly we are talking about the double charge, but where does it actually happens? Now, when you say, okay, charge me for cone 7, and you never got the response back, and you again said it, charge me for cone 7, because you thought that other person never heard you, but for real, that person actually heard you and started making the cone for you. Now, second time when you said, the person thought, okay, it's a second request from the same person, and started again the preparing the cone for you. Now you have to pay for 2 cones twice. The danger is one precise moment you paid, but the done never reached to you. Okay, so you repeat. If the truck can't tell your repeat from a brand new payment, you pay twice. Everything before paying was harmless. This single step is where the stable name payment ID becomes the mandatory. The truck checks 7 number, already paid. Here is your code. instead of charging again. Now, what if you never hear back at all? This is also very interesting, and this is, I want to show you the different version of it. So for example, this is your mobile app. Your mobile app says that I want to make payment of 150 rupees to your server. Your server goes to the payment gateway and asks, hey, this person whose name is Gigi wants to pay 150 rupees. Can you please create one intent? And this payment gateway would create an intent saying, okay, XYZ is his intent. This XYZ is saved in your cache and you give it back XYZ to mobile user. This is phase one. I'm calling it phase one. Now in phase two, what happens? Your mobile application would say, with this intent ID, can I make a payment of 150 to server? Server says, yeah, sure, why not? And then there is a gateway. Gateway says, payment is done. And server saves this payment operation in the cache or DB, wherever you want to save. But while giving this response back, this network interrupted and it never reached to the user. In this case, there are two ways to do it. One, when server is saving the payment status in the database, there should be one service, which we call it notification service, should also tell this to the mobile client that your payment is done. Now, whatever payment you would make will be on the new intent ID, or either it is done or there is an error. Any of it. You have to say it back through your notification services. Or once user come back to application after closing the app and come back, you can make the call to server saying, hey, what happened to my previous payments? Are those are succeeded, not succeeded? Are there any errors? And server can check the DB and can tell you, okay, yeah, your last payment was done, so don't worry, your wallet is updated now. So this is something which we call reconciliation when you come back in case of you never heard back from the server side. And this is what we are trying to explain it here. The ice cream version, the walkie-talkie dies completely. You left standing there unsure if your cone is coming or not. The truck shouts when it is ready. This is like a notification. Even with no reply, the trucks call out, cone number 7 is done. You find out eventually a webhook or a notification. You call up and ask, what happened to order 7? You check the status of what specific order yourself. Both still use the name. The shout and the question both works because the order has one stable name, 7, to look it up by. I hope you are understanding it from what I'm trying to tell you from a notification or a webhook point. Now the whole flow, mobile says I want to pay, server makes order 7, save 7 for you, pay for 7, charge, server retries if needed, if not, fine, and done. Shout reply either through the response back or through the notification. Now what we answer today is, why not just one stop retry? You can't. You make the repeat safe instead. Who names the order? Who creates the ID? The side who retries. Always understand this problem statement. Client can also create the idempotent ID. When I say client, that means mobile application can also make the idempotent ID. The only thing is, then you have to rely on the mobile side to retry every time, even with the payment gateways. You cannot just say that I will only go and check with the server. I will not go to the payment gateway. This time you have to go till payment gateway to do the retries. Now, all these steps need that much care? No. So reserving is sloppily safe. What you can do, actually, you can save the space or save the idempotent ID with the caching system. If somehow it never reaches back to the client, it's okay. Client can start a new request saying that, okay, I want to create another ID. Where is the double charge? I explained you when the double charge actually happens, when you are using the same ID and you are making the same call again. Same name, different order. This is something, suppose you are saying that, okay, this is order XYZ, but first you said that I want to pay 150 rupees, but next time you're saying this is still order XYZ and I want to pay 200 rupees. This time the payment will not happen because your identity is still the same. Your identity haven't changed. When I say identity, it can be your token, your name, combination of all. So when you start an intent, that intent also saves your identity against the payment. So you cannot have a two different number of payments like 150, 200 or 2000 rupees on the same intent. If you are starting one intent, you have to go with the one payment. For another payment, you have to start another intent. Never hear back. Truck shouts is equal to webhook. You never heard back, it's okay. If the payment happens, doesn't happen, doesn't matter. It will come back to you through the notification, or you refresh your page once you come back in the application. Now, idempotency means repeated request lands on the same results, not the second one. It's only mandatory on the step that moves money. And it works because the caller reuses one stable name across the retries. I think same name every repeat. That's the whole secret. I hope you understand the idempotency and the questions, follow-up questions behind it, how to answer those. Most important question, who creates the idempotent ID? What happens if you never heard back? And how does the notification or webhook works? So we are going to get a new topic on every week. So stay tuned. You're watching Underflow with Chichi.